Let's solve a binary tree related problem from LeetCode. It's a easy problem. Let's understand this and then we'll write the code. So the problem says to find diameter of the binary tree. So this is a binary tree, and from here we need to find the diameter. So if I say, like for this node, what is the diameter? Then we find this length and this length, and you just add this. So we'll say the diameter is 2 here. For this node, if I say what is the diameter, then I'll find the length in the left side. So this one and this one 2, and then this side 1. So 2 plus 1 3. So that's we need to find out. So how to write the code for this? So we need a traversal, and we have seen many binary tree related problem using the recursion, where we have done the left traversal and right traversal. Here also we do the similar logic. I will do the recursion. I will call a recursion for the left side and the right side. And when I call for the left side, I'll just go, when I call the left again, it will call left again, call left, and come to this place. Once left is done, then for each node, I have to call the right also. So for each, like for this node, I call the left and the right. So the left call happens, it goes where right is pending. From here again, the left and right, left call happens here, right is pending, and from here again left. So for the left call, there is nothing, I will return 0. Here right call, nothing, I will return 0. So for this 4, when I call for this 4, the recursion, the result will be 0. From here, I need to call the left and right both. So for this, there is a distance 1. So when I return this, so whatever the result for this plus 1. And here also, whatever the result plus 1. And then I'll find what is the max of that. So that's the max distance, for this node. What is the max distance? I will return that. So in this way, and also at the same time, it's also return the max distance, and also same time, I also calculate the diameter, that is this length and this length. So let's see the code that, and you'll find the similar logic, whatever I have used in other problems also. So I'm going to write one helper function for this. So func, and this is going to return int, and this is the helper function. Let me call this function, and I'll just say diameter. So diameter is 0 for now, and here also diameter int. I'll call this function, and I'll pass the root and then address of this diameter, and this is the pointer, so just I'll put the pointer. So this kind of the global variable. Here I'm passing the reference, and then when I find the diameter, I will update this diameter, and then I can return the result here, return diameter. Yeah, so write a variable like a diameter or result, that's fine. Okay, so when I come to this place, the first thing is, let me call this function, twice. This is for the left recursion, so it's a left, and then this is the diameter. So this time I don't have to pass the address, and again call for the right. Right. So see here. So when I call this function here, it will come to this place, and then left. So it will come left. Left goes left, and see the right person that is remaining. So when I come to this place, I have to check if it is null, then return 0. So let me add that code also. If root is equal to nil, then return 0. And in this case, I want to store the result in a left, and then this is the right variable, and then I want to return, like if I come to this place, and there is nothing, so return 0, and the right call, there is nothing, return 0. So it will return 0 here for this 4 node, and when I call one go above, one above, then from this, if I call this, I want to return this, like this result plus 1. So what I do, I'll just say I need to have one max function. Let me write this max function, a b int, if a greater than b, return a, otherwise return b. Okay, so return, I can say the max of this left comma right plus 1. So that's what it's going to return, and that is the length. So that is the length from this node to this node, or from this node to this node. So it will find this length, find which is the max, and then plus 1. It will return that. And here we also need to calculate the diameter, and let's store that diameter here. So diameter is equal to diameter plus left plus right, left plus right. So this one, and whatever the diameter is already there, that's one. So let's run this. Wrong answer. Why it is the 5 and expectation is 3. So this is the diameter and the left right, and okay, and what, so when I add this, okay, no, so I need to add the left right, but we need to find out what is the max diameter there. So I can use the function max here. Let me run this, accept it, submit. Yeah, so that's the logic, and this is the whole code. Main logic is this. That's just a max function. Let's see the Java solution. I have used exactly same in a Java solution. Variable might be different a little bit, but yeah. So I created one private result, and I'm passing. Uh, I'm calling this diameter, and this result is global for this function. And again, max left plus right plus 1, and then when I calculate the diameter, the max of this result, whatever, and then left plus right. So that's all for today. Thank you.